So for today's lesson, I'm going to be reviewing rules of exponents / laws of exponents. So let's get straight into it. There are 7 different rules that I'm going to go over in this video in regards to exponents and how we would solve them in various types of mathematical situations. So we're going to start with the first one that I have listed, which is the product rule. So the product rule looks like this. So this is the product rule. And so as you see here, I wrote an example. I have x raised to the 5th power times x raised to the 5th power. So I wrote it right here, and I also wrote it again right here. So the only difference with these two is that the multiplication sign in this first one is a cross, and the multiplication sign in this one is just a dot. So I wrote that just as a reminder, or to let any students know that may not know, you can write multiplication signs in those 2 different ways. Most likely in a lot of situations, especially when you're dealing with variables, you'll tend to see multiplication signs that look like a dot rather than an X, just so that we are not confusing the X sign of a multiplication sign with a variable. So now that we've gotten that disclaimer out of the way, the product rule is when we have 2 like terms. And these are like terms because they have the same variable. So we have 2 like terms that have exponents, and in order to simplify this expression, we want to combine the exponents by adding them. So as you see here, I went from x raised to the 5th times x raised to the 5th equals x raised to the power of 5 plus 5, which ultimately equals x raised to the 10th. So whenever we're thinking about this first rule, which is the product rule, we associate that with multiplication. We know that whenever we have an expression written like this, where there's multiplication involved, we know that if they are like terms, that we're going to combine the exponents by adding. So when you think of product rule, think about multiplication and addition. I wrote basically another example under this. And we have our like terms, which are the 2 x's, but then we have different exponents. So we have x raised to the 9th times x raised to the 6th. And so in order to simplify this expression, once again, the product rule, we have to combine the exponents by adding them together. And when we do that, we get x raised to the 15th. So that is the product rule. So moving forward, we have the second rule, which is the quotient rule. Now the quotient rule is the complete opposite pretty much of the product rule. With the quotient rule, instead of dealing with expressions where we are multiplying, we are dealing with expressions where we are dividing. The example that I have here is x raised to the 8th power divided by x raised to the 3rd power. So again, this expression is being divided, and in order to solve this, we have to subtract. So we have to subtract 8 from 3, and that gives us 8 raised to the 5th power. So like with the multiplication or the product rule, I said, when you think about the product rule, you're thinking about multiplication and addition. The quotient rule is the complete opposite. The quotient rule, it's dividing an expression using division, and you're going to have to subtract the exponents. With the quotient rule, or just division in general, you can write the division sign as we all know it like this, but also we can express or illustrate division by kind of writing a fraction. So we could also write it like this. So even when you see this, you should still know that you're using the quotient rule. And so here again, I have x raised to the power of 8 divided by x raised to the power of 3, and I'm still going in and I'm subtracting my exponents to get the same exact solution. Moving on to our third rule, we have the power rule. So this is a bit less chaotic or more simple. I don't know. It's all new. It's all different, especially if this is a new concept to you. So we have x raised to the power of 4. So this right here, this expression is raised again to the power of 6. So whenever you see this, you know that you are multiplying. So I'll always know that you're just going to multiply those two exponents together. So whenever you see expression written like this, whether it has a different variable or different numbers, if it's written in this format, we know that we're just going to go ahead and combine those exponents by multiplying them, and that's how we get our answer, x raised to the power of 24. So again, if I'm going over this a bit too quickly, feel free to pause the video and also pause the video and spend more time on the solution. If you like a video with me doing more practice problems, let me know in the comment section. And yeah, so we have the fourth rule, which is the zero exponent rule. I wrote the zero rule exponent, but it's the zero exponent rule. So this is it. And this rule is quite simple as well. Whenever you have a variable or a number, any number, whether it's a negative number, a fraction, a decimal, even if you have a variable, the zero rule basically says that whenever that number or variable is raised to the power of 0, you're always going to get a 1 as your solution. I use the example of x. So x raised to 0 equals 1. But that's a variable. But we also know that 5 raised to the power of 0 is also 1, and that's an example of a number. But we could plug in any number for that. 5 just happens to be my favorite number, but if you decided to do 100 raised to the power of 0, you're still gonna get 1. So moving on to the fifth rule, which is the fractional exponent. And it looks like this. So basically, this is all about formatting. This is getting into more advanced math. Again, whenever you have an expression like this, don't get too overwhelmed. No, you can always use your calculator depending on what math class you're in or what your teacher approves of or doesn't. But this is pretty much all about like how you would write it out and simplify it. So this is the fractional exponent. So we know we're dealing with fractions. So we have our variable. This could also be a number, but we're just using a variable raised to the power of a fraction. I wrote 2/5. I wanted to color code it so that it makes sense where it's going. You write the variable with this radical. And on the inside of the radical, you put the numerator, which is 2, and I highlighted that in yellow. You put the denominator, which is green, I highlighted in green, outside of the radical. And this is how you would write it to simplify it. Okay, so now for the second to last rule, we have the power of a fraction rule. I just wrote power of fraction rule. So again, we're using parentheses again, but this time we're actually distributing and using a bit of the distributive property. So here we have x over y in parentheses raised to the power of 5. There goes my lucky number again, or my favorite number. And we would simplify this expression by writing x raised to the power of 5 over y raised to the power of 5. So as you see here, all we did was distribute that 5 on all sides, to both variables. And that is the rule. So our last rule is the power of product rule. So again, we have our parentheses. So with this, we have x times y in parentheses raised to the power of 3. And because we have parentheses, we want to distribute this exponent to both variables. And so that's how we would simplify it. So I hope that makes sense. Before I close out this lesson, just want to make note of a few things. I use variables for a lot of these examples that I just did. If you were to, for instance, plug in a number to this, you would still go through the same exact thing. So let's say this is 5 and this is 2. So you're raising, so this is, what did I say? This is 5 and this is 2. So this would then become 5 raised to the power of 3 times 2 raised to the power of 3. And then if you go back to my exponents video, we know exactly how to write that out and solve that. Or again, you could just easily plug that into your calculator and get the answer. But since we're dealing with variables, we just get a simplified expression. Another thing I want to make note of is the fact that whenever we have parentheses, as you've seen or you just saw in these last couple of examples, we're always going to distribute, because parentheses basically symbolize like a unit. So for instance, I'm just using this example since this is the last one. This is all together. That's what the parentheses are doing. And so that's why we have to distribute this 3 to both terms. Hopefully that makes sense. But distribution, PEMDAS, parentheses, that's something I can get into in later lessons. Again, if you have any questions, comments, concerns, feedback, please let me know down in the comments below. I'd be happy to respond and help out in any way I can. So yeah, bye.